Welcome back, Math 2. Today we're going to start Unit 6, which is going to be about similarity. So we're going to do a quick review of dilations, which we learned about in Math 1, and use them to talk about our similarities, okay? So remember last year we had a unit on geometry where we learned how to do a lot of things to shape, rotate, reflect, translate, and one of them was a dilation, okay? And just like you think of like your eyes dilating, and your pupils get bigger or smaller because they're adjusting to the light, our shapes are going to get bigger or smaller because we are going to multiply our coordinates by our dilation factor. Okay, it's often also called the scale factor. Okay, so let's go ahead and do the first one here. I have this triangle NXV. And the first thing I'm going to do is just real quick write down the coordinates so that I have numbers to work with. So here's 0, 0. So N is at 0, 4. X is at -1, 1. And V is at 3, 2. Okay. They tell me I'm going to dilate by a factor of 1/4. So I'm going to multiply by 1/4. You could also use 0.25. Okay, so I'm going to take all of these numbers and multiply them by 0.25 in my calculator, and then I'm going to graph those new coordinates. Okay, so my first one, I'll get 0, 1. So there's my new N. For X, I'll get -0.25, comma, 0.25. So that's going to be really small. It's like right there. Okay. And for V, well, let's see. For 2, I'm going to get 0.5. And for 3 times 1/4, I'm going to get 0.75. So it's most of the way over and halfway up. So that's my new shape. It's very, very small. Okay. Let's do the same thing with number 2 here. So again, I'm going to write down my coordinates, A, W, U, and G. And here's 0, 0. So A is at -2, 3. W is at -2, 0. U is at 1, 2. And G is at 2, -3. Okay, I'm going to multiply all of them by 0.5 or a half. I'll get -1, 1.5, -1, 0, 0.5, 1, and 1, -1.5. So again, I'm getting smaller. All of my shapes are getting smaller so far. So -1, 1.5, -1, 0, half and up 1, and then over 1, down 1.5. There's my new shape. Okay. Now, when we dilate a shape like we're doing, we get similar shapes. Okay. Let's real quick skip down just to number 10 here. Okay. They have the coordinates and they just want us to do a dilation of 2, which again means we're just going to take all of these numbers and multiply by 2. So my new x coordinate, if I multiply -2 and -1 both by 2, would be -4, -2. M would be -4, but still 0, because 0 times anything is still 0. H would be 2, 4. And K would be 4, 4. So let's flip to the back here. Okay. So last year we spent a lot of time in our geometry unit on the idea of congruence. Okay. So two shapes are congruent when they meet two qualifications. Okay. By the way, there was a symbol for congruent that you might want to remember. It was an equal sign with a little squiggle over it. So two shapes are congruent when they are the same size and shape. Okay, they had to be exactly the same. Okay. This year, we're going to focus a little bit more on the idea of similarity. Okay, so two shapes are considered similar, which, by the way, there is a symbol for that. It's very similar. It's kind of like the congruent symbol, but it's just the squiggle, no equal sign. Okay, so two shapes are similar when they are the same shape and proportional size. Okay, so let me tell you what I mean by proportional. Okay, so proportional is probably a word you have used before, heard of. It means that everything kind of matches in size or it makes sense in size. So, for example, if there was a person who randomly had a very, very large hand and then had a really, really little hand, you're like, that doesn't make sense. Maybe something's wrong with them medically, or maybe whatever. But the point is, like, a little kid's drawing tends to be not proportional, where someone who's more skilled as an artist draws things proportionally. Or like the sizes of our houses are proportional to the fact that people live in them, like people our size live in them. Um, or like my toddler does not eat as much food as I do simply because she's only 3 feet tall and she's a lot smaller. Okay? So, how do you know if something is proportional or not? Well, that is determined by the scale factor. Okay? So, a scale factor is also like the dilation factor. Okay? Basically, what happens is if I can say, okay, this box and this box are going to be proportional because this side has all sides of 1 and this one has all sides of 2. Okay, they're both the same shape, they're squares, and they are proportional because to go from one to the other, I multiply by 2. So it's basically, what do you multiply by? Okay, so two figures are similar when they are the same shape and you can use the same scale factor for all the sides.